Chapter 7. Introduction to Writing and Balancing Chemical Reactions. This is the language of chemistry. We can often see evidence of a chemical reaction. We might see flames from burning, which is a chemical reaction always, or we might feel heat being released. We might pour two liquids together and find a precipitate forming, or we might drop a substance into water and see bubbles forming, or we actually might see something glowing, giving off light. You can easily be fooled, however. Some bubbles are just like water boiling. It's not a chemical reaction. No change in state is a chemical reaction. The bubbles are just a gaseous form of the same substance, liquid. A chemical equation looks like this: two substances reacting to form two new substances. We can represent these chemical equations in a certain way. The substances on the left are the reactants. The substance on the right of the arrow are the products. We often specify the state of each reactant or product in parentheses next to the formula. These abbreviations are in parentheses G for a gas, L for a liquid, S for a solid, AQ for an aqueous solution. Here's an example of the combustion of methane. The reaction occurs in a natural gas flame, which is methane. The formula is CH4 for methane, reacting with oxygen, O2, to form carbon dioxide and water. This would be the word equation. So we represent this equation as a chemical equation, writing down the reactants, methane, oxygen, reacting to form carbon dioxide and water. If we add the states, that makes it even more clear. This is a gas, another gas reacting with carbon dioxide, a gas, plus water, a gas. The combustion of methane, is this equation balanced? Well, we can look at a picture of it and we see that we have two oxygen atoms. We have two oxygen atoms as a product, but we have one more. So 3 on this side, 2 on this. It's not balanced. Neither is the hydrogen. 4 here and only 2 there. The carbon is balanced 1 and 1. So we need to work with this equation to get it to be balanced. The number of atoms on each side has to be equal in count. It's the law of conservation. So this is the situation. To correct this, we must balance this. The way in which we balance this is by making more than one of each type, and that is represented by inserting coefficients in front of the substance. So this 2 means 2 oxygen molecules, pictured here. And this 2 means 2 water molecules, pictured here. And so this has balanced equation. If you note, you'll see the 4 hydrogens here, 4 there. 4 oxygens, 4 in the products. 1 carbon, 1 carbon. So this equation is balanced by adding the coefficients in front of the chemical. We want to check and see if this is balanced. We use sometimes what is called a rep table: reactants, the element, and products. So in this, we look at the element carbon. In the reactants, we just see we have 1 carbon, and in the products, we see we have 1 carbon. Hydrogens, we see have 4 hydrogens here. In the products, we have 4 hydrogens in 2 molecules of water. And the oxygen, we have 4 oxygens in 2 molecules of oxygen. And we have 4 oxygens, 2 in carbon dioxide, and 1 in each of 2 water molecules. So this equation is balanced. How do we write balanced equation? Well, we first of all write a skeleton formula by writing the correct chemical formulas for each and every one of the reactants and products. Don't omit any one of them. If an element occurs only once in a compound, in only one compound, that's a good element to start with. Begin to balance it first. Very often this will be the metal rather than a non-metal. If an element is a free element, use it, save it till last. And finally, when you do get it balanced, check the final balance by using a REP table so that we can count each element in the products. Here's an old lime oven found in Africa in which they would take calcium carbonate and make a cement substance, maybe make bricks. Limestone is heated in one such oven-like, and it releases carbon dioxide gas, and it's converted into a substance called quicklime. Now this quicklime, if you mix it with water, then is slaked lime, and it gives off heat. Here's an interesting, how could we translate these word equations into chemical equations? We first of all have to know the chemical formulas of each reactant and product. So limestone is calcium carbonate. Calcium is group 2A, so it's a +2. Carbonate is a polyatomic anion, -2, so 1 to 1. Quicklime is calcium oxide. Again, group 2A is a +1 metal, and oxygen is -2, 1 to 1. And slaked lime is calcium hydroxide. Calcium, again, the +2, but the hydroxide polyatomic anion is -1, so we need to take 2 of those. Put them in parentheses and take 2 of them. We also have water, H2O, and carbon dioxide, CO2. So let's do the translation. Limestone, there it is, calcium carbonate, reacts to form quicklime plus carbon dioxide. This equation is already balanced, you can tell. 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. Then water is added to quicklime to make slaked lime, and heat is released. Here's that reaction. Quicklime plus water forms this. And again, you can see this equation is balanced. 2 hydrogens, 2 hydrogen, 2 oxygens, 2 oxygens. Now our final exercise is to write a balanced equation for a reaction which is described as gaseous nitrogen dioxide with gaseous hydrogen to form ammonia and water. So this is a molecular compound, nitrogen dioxide. Water is a diatomic element, hydrogen is a diatomic element, H2, and ammonia is NH3, a molecular compound, and water. If we look at this, we see that hydrogen is in 2 compounds on the right-hand side as a product, so let's not begin there. But we can look at the oxygen. You see you have 2 here and only 1 there, so let's put a 2 in front of that to make the oxygen balance. Okay. Now note that because you have the subscript 2 by the hydrogen, you can never have any more than an even number. If you put a 2 here, you got 4. If you put a 3, you got 6. You'll have to have an even number. And this is an odd subscript, so you're going to have to put a 2 in front of that to make it 2 times 3 is 6. Okay? So if you put a 2 in front of that, you've messed up the nitrogen. So now you have to come back and put a 2 in front of this, so the nitrogen is balanced, and that now makes the oxygens messed up. 2 times 2 is 4 oxygens. You're going to have to go back here and change that 2 you put to a 4. Okay, so that might do it, and then we'll work on the hydrogens. So we have our 4 here, takes care of the oxygens, 4 oxygens, 4 oxygens, nitrogens 1, 2, and 2, and now the hydrogens here is 6, times 3 is 6. 2 times 4 is 8. 6 and 8 are 14. Come back and put a 7 there and you have 14. Check it out. For nitrogen, 2 nitrogens and 2 nitrogens. Oxygen, 4. Hydrogen, 14. 2 times 3 is 6. 4 times 2 is 8. 6 and 8 are 14 hydrogens. Check, check, check. Balanced. So remember this. You are fluent in chemistry when you've mastered writing and balancing chemical equations. Enjoy this part of the chapter.